Hello guys, so the topic that we're choosing is statistical process control. Before that, I want to introduce you to my group first. That includes me, Zefanya, Jevan, Joyceline, and Tiffany. So, statistical process control is the use of statistical techniques to control a process or production method. That includes X chart, R chart, and the equation that follows it.
Statistical process control can be explained by several theories and concepts. One of the key theories underlying SPC is the theory of variation. SPC recognizes that all processes has inherent variation, which can be categorized as common cause variation and special cause variation. The founder of SPC is Walter A. Stewart theory of variation, often known as Stewart theory, is assert that all processes has some level of inherent variation due to things like different pieces of equipment, different batches of raw materials, different environments, and different level of human invention. It is critical for processes control and optimization to recognize and account for this variation. Natural process variation, sometimes just called process variation, is the statistical description of natural fluctuations in process outputs. Plannable cause variation is unnatural variation in a process. It should be identified and addressed. Control chart enable us to determine the type of variation that exists in a process. A common problem in a business is managers who treat all variation as it is were due to assignable causes. SPC requires control chart. This diagram shows the average process over time and how much it can alter. Control chart determine if a process is appropriate or has a special cause of change. Control charts vary by data type. X bar chart tracks process means, while R chart tracks variability. The central limit theorem is a fundamental concept in statistics that is relevant to statistical process control. It states for a large sample size, the distribution of sample means or sample proportions from any population with approximate abnormal distribution, regardless of the shape of the original population distribution.
Capability, analyzing a process's innate capacity to conform to a client's set of requirements. It assesses whether or not the process can reliably produce within the specified tolerances by comparing the process's variability to those limitations. The probability distributions of a statistic is known as its sampling distribution. Once sufficient samples have been taken from a given population, it gives an overview of the probabilities surrounding a statistic, like a population's mean or mode across a given interval.
Right, hopping into the calculation. The first one we have is an X chart. A control chart consists of the center line, an upper control limit, and lower control limit. The center line is the X double bar, which is the mean of the sample means. UCL's formula is X double bar plus A2R bar. We can find the number of the A2 on the control limit factors table given here. On the other hand, the formula of the LCL is X double bar minus A2R bar. Basically, it is similar to the UCL with a difference in the plus and minus. R bar is the average of the sample range. By using this, we will find whether the process mean is in statistical control or not. Before we do all these, by using this, we will find whether the process mean is in statistical control or not. Before we do all these, we have to find the R and X bar first for each period. It can be in day, month, year, or any other variables. After that, just put it into the formula. If we want to see it easier, we can draw the graph of UCL, center line, and LCL just like this. Put in mind that this is just an example.
Next, we have the R chart. It is a statistical control chart used in a quality control to monitor process variability, and it is usually combined with an X chart or X bar to provide a comprehensive view of process performance. An R chart shows the range of values within each subgroup or data sample. The purpose of the R chart is to determine whether the process variation is within tolerance or whether there are points out of control that indicate a particular source of variation. It helps detect changes in process variability that can affect product quality. Multiple subsets of data must be collected, typically with multiple measurements per subset. R is computed by taking the differences between the maximum and the minimum values within each subgroup. Here are the steps to create an R chart. First, collect data. Obtain multiple subgroups of data, each containing a fixed number of measurements. Second, calculate the range. For each subgroup, calculate the difference between the maximum and the minimum values. And then, calculate the R bar. Calculate the average of all ranges obtained from the subgroups. Next, determine control limits. Calculate the UCL and LCL for the R chart using the formulas. For D3 and D4 are constrained based on the subgroup size, which can be found in the statistical reference tables. Lastly, plot the R chart. On the vertical axis, plot the range values for each subgroup, and on the horizontal axis, plot the subgroups or sample numbers throughout the UCL and the LCL lines. And when interpreting the R chart, the range values are compared to the control limits. A process is considered to be in control if all points are within control limits and exhibit random variation. If the points fell outside the control limits or showed a non-random pattern, this indicates a particular cause of deviation, and the process should include investigation and corrective action.
Thank you all for watching our video about statistical process control. Hope you guys enjoy this video and hope this video will be beneficial for you and give you enough information about statistical process control. Goodbye.